I'm Shaun. Shaun Wei. I'm the CEO of RealChar, and I take my morning coffee with oat milk. I do usually do half coffee, half milk. I do like canned sugars, and I like to light my days up and have a little bit sweet in my mouth.
What's going on, everyone? Welcome back to another MLOps.community podcast. I am your host, Dimitrios, and today we're talking with Shaun all about what he is working on, his product, Rivia, and the company, RealChar. Oh my God, I love it. I'm so excited by what he's doing because it is a consumer application using Gen AI and traditional ML, and he basically pulls open the curtain to show us what and how they are combining the two. I cannot say I fully understand what exactly he's doing, but he broke down for me after we stopped recording, of course, this idea on how in robotics, it's very common to run everything in parallel and look at something, I think he called it design OS. And everything needs to be done in parallel so that you can scale and so that you can do things quickly. Now, his product is a consumer app that you can basically use AI to call different customer service lines and have AI take your customer service burdens off your shoulders. So we as consumers are getting put up to the task of having to deal with a bunch of shitty AI. Why don't we fight back by giving all of these shitty implemented AI, probably a little bit half-baked AI solutions that are everywhere with enterprises and companies? Why don't we start to implement our own? And so that's the idea. You get AI to make calls for you, wait over 3 hours on a customer service phone call and press buttons for you. If you'd like to go to whatever, be transferred to this, then press 1. So they're doing incredible things with that. If you want to check it out, you can go to revia.tech/signup. We left the link in the description. I know I've already signed up because I get the feeling it's not going to be fully polished. He said it in the call right now. He said, you know what? It's not like we are 100%. We're basically, if you analyze this like a self-driving car, we can get the car to drive straight on the road for 15 meters. And so going into it with the expectations that it's not polished, but it is going to be something that is immensely valuable if it can at least offload 10%, 15% of those phone calls that you have to make that you don't want to make because they're unnecessary. All right, that's it. Let's get into it with Shaun. As always, if you enjoy this, share it with one friend so we can get the word out about the good old MLOps community. And Spotify has that cool feature where you can leave comments. I read them all, the good and the bad. Actually, I love the bad ones. Talk as much shit as you want to me. That is my daily fuel. I'll see you on the other side. So, Shaun, dude, I'm excited to talk to you again. I know that we had our first conversation on the Deepgram podcast that I run, and we got to talk about your founder's journey and being a founder and what it means to develop AI products these days. But I told you, come on the MLOps community podcast because I had such a great time talking to you and learning from you, and your experience in being like in the weeds on the engineering is so valuable. And so being a technical founder that you are, I thought you would be able to still talk to us about coding and some of the stuff. Really putting AI into production is, I think, the theme of today's chat that we want to talk about. But as a quick overview for those who did not listen to the AI Minds podcast that we did, I want to let everybody know that you were working on Google Assistant, and then you transitioned from there you said, you know what, I'm going to go do something a little bit more audacious and help build self-driving cars. You were doing that for a while, and I guess all the while you had this bug that was telling you there was something there when it comes to Google Assistant. And so now you started your own company. You guys are about to be featured in the next YC batch, and it's all about assistants for humans. And so let's just break down a quick overview of what the product is before we go into the tech of it.
Yes. So what we build is called Rivia, Revia, and we are like soon to have a version on the App Store. So I think by the time like you listen to the podcast, you should be able to download that. But we're still doing like a small beta testing right now, and hopefully I can give this like AI assistant to power your daily life.
Yeah. And is it only in the US?
It's in the App Store. I think we can open up to all the like regions.
Oh, so that's ambitious, right? Because there's so many different cultural things and languages and pieces that you have to deal with, especially when it comes to me not knowing. Basically, you're making it open-ended. You're saying that this tool can do anything that you want, right? When it comes to like dealing with customer service type issues, phone calls with products or product companies. Like I think about my mobile company, they call me all the time trying to offer me upgrades, and I just want to know what the upgrade is. I don't want to sit on the phone call with them for a long time. Or if I need to get my plumbing redone, I break a pipe or something springs a leak in the house and I need to have a plumber come by, you can go and have the AI assistant call the plumber and schedule a time for them to come over, and you just get a text message that says plumber will be over in tomorrow or Tuesday between 4 and 6, something like that.
Yeah, that's the hope, right? So like based on my past experience, like that's people really want. Like they want using the AI to replacing you in those like really boring phone calls. So that's the mission. Like we're building on this. Like people should be spending your time on meaningful tasks with your families, with your work. You don't want to like really spending 2 hours like dealing with like the plumbers, dealing with like your like utility companies.
None of them. Yeah, like the least amount that I have to be organizing my life, the better.
Yes,
that is for sure. Dude, that's the vision. There's a ton of technical challenges that you have with this. So why don't you walk us through what some of these have been and how you've taken, like, I imagine you had a ton of learnings when you were working on Google Assistant, and that was back in the day. I remember being so inspired when I saw that. And I remember a specific point in my life when I saw that and I thought, wow, the world's going to change if this is real.
Yes, I think the Google Assistant capability you were referring to was Google Duplex. So Pichai announced the Google Duplex in Google I/O, I think 2018, when this AI was supposed to representing you to make phone calls to book hair salons for you, book like restaurant for you. So I was actually on both ends, right? So on the building end, on the receiving end. So I interviewed the people like from both ends. So what I found was, first, during 2018, we were trying to build an NLP and NLU model that can handle natural conversation in a phone call setting. It's extremely hard. You have to have a ton of labeling data to handle a lot of corner cases when you're trying to make it sound natural, right? So it requires a ton of training, and it's spending a larger team actually just making that 2 use cases, and it may not work most of the time, right? So that's on the engineering side. Like during that time, it's really hard, and we don't have a larger model by that time. So what we did was trying to do a lot of classifications, right? Whenever you're trying to say, okay, I want to book a hair salon in this location at this time. So we capture those intent, trying to understand the user intent and map those to the actual sentence, right? So the audio bytes. So during that time, we were using, I think, CN or RNN models, trying to do that. And there's NLPs in the front to do the intent classifications. Then there's like the speech to text, text to speech. So in the end. So but CNRN was like running extremely fast. So that's like a advantage over like the larger model, right? But on that part is like, since there's so many intent you have to capture, right? There are so many corner cases. When I interview the other end, like who were receiving the phone calls, they're very, very interesting. Like for them, it's a little bit odd in the beginning, right? There's like there's AI starting calling them. That's the first experience. They starting to experience, oh, there's AI actually holding like another conversation with them. Then soon they realized the AI wasn't able to handle all the like cases like humans. So one of the examples they gave me was they were a hair salon. So they were trying to receive a phone call from like the Google Duplex saying, okay, the client wants a haircut. So, but when they ask like, what type of haircut? Do you want like a female like haircut or like a male haircut? That's when the system break. So that's why like during that time the NLP wasn't there to understand all the like smaller cases. That's what eventually break. And I think they were eventually receiving like human phone calls. So I think Google might be using like human to represent the users to call them. It's just like so hard. During time, we realized people really want to kind of hand off this phone call experience to the AI assistant, because those are really boring and the phone call by nature is a blocking experience, right? When you're making phone calls, you cannot do anything. So people really hate that experience. So that's why I got a lot of inspiration from Google Duplex when they made that like work.
All right, real quick, let's talk for a minute about our sponsors of this episode, making it all happen, LatticeFlow AI. Are you grappling with stagnant model performance? Gartner reveals a staggering statistic that 85% of models never make it into production. Why? Well, reasons can include poor data quality, labeling issues, overfitting, underfitting, and more. But the real challenge lies in uncovering blind spots that lurk around until models hit production. Even with an impressive aggregate performance of 90%, models can plateau. Sadly, many companies optimize for prioritizing model performance for perfect scenarios while leaving safety as an afterthought. Introducing LatticeFlow AI, the pioneer in delivering robust and reliable AI models at scale. They are here to help you mitigate these risks head on during the AI development stage, preventing any unwanted surprises in the real world. Their platform empowers your data scientists and ML engineers to systematically pinpoint and rectify data and model errors, enhancing predictive performance at scale. With LatticeFlow AI, you can accelerate time to production with reliable and trustworthy models at scale. Don't let your models stall. Visit LatticeFlow.ai and book a call with the folks over there right now. Let them know you heard about it from the MLOps.community podcast. Let's get back into the show. All right, so moving on from that Google experience, you still set out to create something that is more open-ended, and that just feels like really hard. How have you been able to deal with some of these issues that you encountered back in 2018 when you were doing this? Now is it just, okay, cool, NLP is much better with transformers and OpenAI, or is it a much more in-depth problem than that?
Yeah, I think the first experience I learned from Google was for a lot of scenarios cases, you have to do like human labeling. or you have to have some type of fallback mechanism, right? If it doesn't work, if you still won't get this work done, you have to have some type of fallback. I also learned how human interacts with AI for the first time, right? What are the how they actually train themselves to be able to understand like AI. Then I think the second experience when I'm building self-driving car, that really helped me to understand, to deploy an AI in a actual world, right? Thinking about so we can talk more about like what I have learned in self-driving cars, and or if there's any specific topic you want to like me to like discuss a little bit more.
Yeah, I would love to go into that, because it basically went from like, now you're almost learning about the way that humans interact and the design piece, the product piece. And then you went into the technical piece and you were like, all right, how do I deploy this and how do I make it super fast, right? Because with self-driving cars, you can't be slow.
Yes. So for the Google experience, I learned like the problem, right, and the potential solution. So then in the self-driving industry, when I was like in Pony, that's when I really learned how to actually solve this. Few things like for self-driving cars, but most people probably don't realize is when you think about self-driving car, it's pretty much the most advanced AI integrated systems human have ever deployed on the road, right? It's trying to negotiate with humans, behave like humans. It's trying to replace a human driver in a way, like using all the
100%.
different AI models. That's like what we have been building for the last couple of years, or the Waymo, all the self-driving car company has been building. It's trying to replace, or at least mimic how human interacts traffics, or like control like cars on the road. A few things in the self-driving cars like I really have learned are, first, like how do you simulate an environment that's safe in a virtual world but still can representing a actual human world, right? Because like it doesn't make sense for a car to like drive around, then hit something, then stop, right? That's not safe. But in a virtual world, you can do that a million times, right? With no human harm in the simulation. Second is like, how do you make everything running super fast in millisecond, but it can still like scale, right? So that's second things like you'll be able to learn like in the self-driving car. The third thing you will learn is like people also probably don't realize is self-driving car is also multimodal in a sense, right? It's have the LiDAR data, the camera data. Later on, they also added like the audio input, because you have to hear the sirens. Because when you hear the sirens, you have to know like where the sirens coming from and how do I pull over on the street that's safe, right? So the self-driving car itself also a multimodal. So we can talk about each one of those, like, and give you a little bit more understanding how the technical behind it to make it more reliable and be able to conquer the actual like tasks in the human world.
Oh, that's so cool, and that's so true. The multimodal. Now, how does that play into what you're doing today?
Yes. So let's start with multimodal, right? When people thinking about phone calls, you think it might be just audio. The reality is a little bit more complex than that. So when you're making phone calls, as a human, what you usually do is you have a mental model of what you're trying to do, like during phone calls. It can be audios. Also, like during phone calls, there's very interesting. There's key button presses, right? So like when you're dealing with all the custom support and everything, you have to understand those like button presses, like, and they take actions instead of just the audio audio bytes you're hearing. And like when you're dealing with a phone call, thinking about the scenario, you usually have to also deal with like incoming text messages, right? So they will say, "Oh, I'm sending you a message or sending you a link to this." It's you the model or the AI we're building. You have to understand. Okay, if you receive something additional than the audio bytes, how do you deal with that? So that's why like the multimodal has to be there before you can complete the circle of like handling the phone calls.
Wow. It's so complex because sometimes you get like, yeah, I'm sending you the text message with your code on it. And then you have to say the code. And so you have to have the system understand all of that. How are you going about understanding it? And it seems like you are really doing stuff with agents that people only wish they could be doing. But from what it sounds like, you figured out a way to put them into production.
Yes. So, like I said, I'm like heavily inspired by the self-driving car, right? Like, self-driving car was able to take the text, or take the audios, and you can also command it, like take the text, take the like different like LiDAR, radar data in real time, and make decisions on those. So when we built the AI assistant Rivia, we used a similar methodology. So the system taking any type of streams, it can be audio streams, can be text stream, can be any type of data, it will be able to understand it on the fly. We have it's also called perception models. It understands like any type of data format and try to understand those like on the fly.
And what does that look like technically?
Yeah, for technically thinking about it's just thinking about the video recording, right? So when you record a video, you have this like audio bytes like streaming in using WebSocket or like WebRTC like to the backend. Then you have the a video stream like that's like the frames also streaming into your backend. So in the perception models, you have to handle like two streams at once, right? Then you have your ML models like once the audio bytes or the video bytes comes in, the models will be able to start to handle those. You can handle those in a batch setting. For example, you can process this every 2 frames, right? Or every like 100 bytes of audio bytes. So that depends on like how frequent or like how fast your system runs. Like for most of self-driving cars, or most of like, if not just self-driving cars, all the robotics, it's like processing the data in a frequency, right? So you see like probably figure, you see like the processing at probably 100 like hertz, right? Or so even more, even faster. So we're adopting the similar technology. Is like the system runs on a clock cycle, right? So once like 100 milliseconds, you're starting to processing all the frames for the last 100 milliseconds. You use that data to generate signals for the downstream systems.
Damn, that is wild. So basically, you're doing it at consistent intervals and just checking out what's going on. And it's almost like you're processing whatever comes in. It could be any modality.
Yeah, any modality, yes.
And then once you get a trigger for a certain modality, you know, okay, if it's speech, we're going to translate that to text, and then we're going to work with that through transformers, like a transformer model, or what is, I'm not sure how you can actually like take action on it. I understand the data coming in part, and then you saying, okay, now we have this data, but how do you actually go and take action on it and do that in a reliable way?
Yeah, so I think eventually it will be end-to-end models, right? So it will be like the any type of data like how the GPT-4o does, right? It will take the omni data like for omni channels like format into the systems. You have dedicated like models. You taking those different inputs, then map to like whatever actions you want to take. For example, it can be speak, can be voice, can be anything. right? It's to eventually will become an any-to-any model. But right now, since we are still in the processing and collecting data phase, right? You do need a lot of data like to train that model. So you will have what I call is more like a like you just described. You have those informations. Then that's when you engage in like traditional like NLPs, right? So you starting to have those like intent or triggers or signals you can use for your downstreams. So for those, you're starting to engage with like the first the traditional NLPs, then there's like the newer generative AIs, because you do have to understand like what's happening like for all the audios like videos like for the last frame, right? So then you use those to generate even more signals, kind of signal or expanding the context. You can think of it that way, expanding the context, just how you do a vector search like RAG, right? So you kind of enhance the context so the model does not hallucinate, right, on a task, because you still in the editor you still need to finish the user's task, right? They assign to you. So you do like the enhancement, do validations. Then for once you have enough like context, you send that to the downstream. For example, if that's a transformer like generative AI models, like then you have a text to speech or like direct like direct like text to text, depends on your output, right? So that's the second part, right? So once you have enough signals, you can use that to ask your generative AI models to generate the response for you.
I like this description of saying you're just trying to gather as much information and as much context through the device itself and through the interaction itself. It's not like you're going to a vector database to gather this information. You're gathering it on the fly with all the different inputs that are coming through on the phone, I presume. It's only through phone, right?
Yes, it's only through phone.
Yeah.
But thinking about like, let's refer back to the self-driving car, right? When you think about when you try to build a self-driving car, what is the first thing you're trying to do? You're trying to ask a self-driving car to start, drive in a straight line, then stop, right? So that's the first simple task you have to ask a self-driving car to do. Similar to our cases, we start with something really simple, right? For example, can it like start making phone calls and say hello to the at the end, then hang up the phone call, right? So once you starting to collect those data, you have better understanding how the AI and the human interact. Just like how you understand like when the self-driving car is going to drive the straight line, like what are the signals it's trying to collect. It's a similar methodology.
So basically, these basic agents are very much like my 14-year-old self prank calling different people and saying hello and then hanging up.
Think about like, we don't want to harm the human in the process, right? So think of like what describe like the virtual world. We put them into a virtual world, meaning like we are not using like the actual humans to sometimes to engage with those phone calls. We have the other end, it can be recorded humans to interact with the AI. So
nice.
It will not be like a lot of random spamming calls. We have this like testing a controlled environment.
So this is fascinating to me because you're training, or it's not training, it's really like validating your capabilities through this virtual world.
Both, right? Like, people talk a lot, especially for generative AI. Like, people talk a lot about like how to create a synthetic data, right? You can think of that as like, we also use that to generate synthetic data, so we can later on use that to train the model. The second is like the validation part, right? You asked me like, the multiple agents, once they hit the human world, it's starting to break, right?
Yeah.
And then, it's so easy to create a really appealing demos with your AI agents, work only 1% of the time. They have recordings and send out, right? But how do you repeat the process, make it reliable? That's much harder. I would think like you spend actually 90% of time effort to make it reliable. So that's why we have this like virtual world that we can, if something breaks, we will able to detect by millisecond what happened on that particular moment. Also I inspire a lot from the RealChar, right? I will be able to detect what happened on a millisecond to find, is that something like related to the generative AI model, or is related to the machine learning traditional NLP NLU model that make the wrong decision, or is that because like OpenAI just went down for like a couple seconds, right? So we have those like simulations like in the systems, so we will be able to like inspect and to kind of fine tune the system in a way that will be able to reliably finish the task you have given it.
Well, I know that the last time we talked, it was how you can hand over the controls to a human almost. And so it's like you have real-time observability to know when things go off the rails. Is that a homegrown solution that you created, or are you using some like Datadog plus whatever like evaluation tool out there? How does that even look under the hood?
If you search like the RealChar.ai, you will find like we have open source projects, right? And my team is really specialized in the audio processing, right? Audio and streaming processing. So we build a lot of WebSockets in a very low level WebSocket to handle all the incoming traffics and forwarding the audio bytes like across different systems. So it's more like a homegrown systems like we have built in-house, and be able to, you were able to pretty much like observe what's going on and take over the control if you think the AI is making wrong decisions. It's also like, like a self-driving or like autopilot, right? So when you can still like supervise the phone call, or you can still supervise the driving. And if you find something odd, like you can always grab the driving wheel saying, okay, I'm in control, right? But when you say, I think it's much safer for you to like take control now, you can still engage the autopilot. I want to build the same experience. I think it's for people didn't realize this. If you're trying to build that like experience, the audio bytes, the audio processing is very hard problem. Because like for text, you don't feel is when you see a text, if it's lagged for a second or 2 seconds, you don't feel the text is lagging, right? So you find, it's fine, it's like transformer is slow. But when the audio bytes slow, you will immediately realize it. Even by probably half second, you will start to realize, there's like really odd audio is starting to cut off or is starting to slow. You will realize it immediately. So that's why like it's require a really fast systems. And when you processing those audios, it has to be really mindful, making sure you don't generate like lags into the systems. That's pretty hard. So that's another hard problem we have realized, or we have like encountered, because how the transformer works, right? If you have ever monitored how the OpenAI give you a response, you will suddenly realize their response is not stable, right? So it can very interesting, like for the GPT-4 Turbo, because we have the internal data, we have internal like benchmarks for all the different larger models, how fast they run and how stable they run. And you were surprised, GPT-4 Turbo, the first token they were running is about 800 milliseconds to 1 second, the first token, right? So that's way too slow for the human conversation, like the real-time conversation. And they were not really stable. So they can go up to like 3 seconds to 4 seconds. And we encountered this probably 20% of time, right? That's the worst for AI agents, right? If you're trying to handle the audio bytes. Then they announced this GPT-4o, right? Like the even faster model. They said, this like is the 50% like latency reduction. So yeah, they were true. Like for the for the launch date, we were seeing like 300 milliseconds, like 500 milliseconds for the first token. But then it's starting to like getting slow again I think with the traffic, like they starting receiving, right? So that's why like I will be super surprised if their like GPT-4 like end-to-end model can reach to the level they demoed like during their like OpenAI Dev Day.
Yeah. Yeah, it's a really hard problem to think about at the scale, and then that time to first token.
Yes.
I know when you think about, I'm sure a lot of people, whenever they think about time to first token and the fast providers out there, I always think about Perplexity and how fast they are. But you can't really use Perplexity as an API, I'm imagining, for your use case.
Well, Perplexity, they do have an API, but Perplexity is they have all their own like models, right? Like I think that's mostly used for RAG, not for a natural conversation. So that's why like when we're finding like the models to make the our solution run faster. So that's why we use like DeepGram, right? So that's why we use like DeepGrams like speech to text and text to speech models. So it's like help us on the both ends try to reduce the latency.
Yeah, and then the models in between, are you just putting something in house?
Because we run everything in parallel, right? So we have built a mechanism like it doesn't matter like if OpenAI is running slow. So there's always easy to fall back to a faster systems. So like the different tiers of systems to handle the like request to make it running faster and accurate at the same time. And also like I said, we have live time, but we have real time tracings on each of the requests. So if it's going beyond certain thresholds, we have a fallback mechanism, right? Think about like so that's why I also use like self-driving car is like if the self-driving car one of the AI models starting to break, does the system going to like stop on the road? This does not, right? So it has a way.
Better not.
Yeah, it has a way to recover itself. So we are using the same mechanism to recover from like if there's any like generative AI models running slow, and we can recover from that.
So I like this design pattern. It's basically saying you have a preferred model that you're going to be trying to use unless it's too slow, and then you have fallback options. And I've also seen a different design pattern where you've got like the gateway, and depending on the prompt, it can choose which model would be best. If it's not that complex of a prompt, it can go to a smaller open source model and save a little bit of money or whatever. But it's a little different when you think about it as a gateway, because you hit the gateway and then you kind of make the best choice from the gateway. What you're saying is we have a priority list and we are always going to try and go for this model, whatever that top model is. But if we can't get that top model, then we're going to try and go down the priority list.
It's slightly more complex than that, right? So there's a priority list for a certain request. So we also have, like I said, like everything is running in parallel. So we have, similar to your gateway, so we have also a gateway for distributing tasks for different like different requests, different prompts, different identified intent. So they all play in a role for the downstream system to decide, okay, should I pause? Should I wait? Or should I like starting press buttons?
Okay. Oh, cool. And I know that you mentioned you are dealing with Gen AI and traditional ML.
Yes.
Are there pieces, first of all, just break down how that looks like, that you have the Gen AI side and then it goes down and it tells the actions to the traditional ML and then it ends there? Or what does that look like, and how do those two play together?
Like I said, everything is running in parallel, right? So you can think of like how I used like the terminal like the event bus, right? So everything happening in millisecond is going to publish into a event bus. So any downstream systems, if you think you can handle the tasks, you're going to subscribe to those events or like in the event bus. Then once you process those, you're going to submits your response back to the event bus. Then the downstream system, if they are interested in your response, still like same layer to subscribe to your event. So that way you have a unified like communication channel, right? So it will like make your system much simpler to handle.
Wow. Okay, this is really cool to think about. So it's this event bus, and basically, if there is the notion that, hey, this might be for me, then whatever the task or the system is going to subscribe to it, and then if it is for it, it'll publish back the results, and if it's not for it, it'll also publish back results like, nope, this actually wasn't for me.
Something like that, yes. Yeah, I'm like the simplest version, right? Like most people can understand, but it's like, in practice, like it's in engineering, it's all in the details. There's so many things you have to make it work.
Yeah, like what?
Yeah, so for example, how do you scale? Right? So that's like a really hard problem, right? How do you scale? Like now you have millions of like requests coming in milliseconds. Remember, you have to make sure the audio biases doesn't cut off, right? In a high resolution and handle like there's like the critical path cannot be slowed down because of you starting to have more events. But then there's things like if the system breaks, you have to fall back. So all of those like play into make the system run faster, right? Yeah, so those are the like a lot of engineering effort going to make the system reliable.
That's it. And for anybody out there listening, we're laughing about the scaling part because I think before we hit record, we were saying that the typical question you'll hear at talks or meetups is somebody has to raise their hand and say, okay, this is great, but how does it scale? And so now we just basically did that to ourselves here. Yes. This is great, but how does it scale? Oh, that is classic. So this is fascinating to think of. I'm still trying to like get the picture in my head, but I think I have a more clear idea of it. Are there other challenges that you've encountered that you're like, damn, that one was particularly nasty and I'm glad I'm over it now?
How I feel is like, I built on the traditional AI. I find everything we're trying to build on the generative AI is nasty. Because you're constantly dealing with like slow response or inconsistent response, or like the agent doesn't behave like what you expected. Or like, it worked yesterday, but why it's not working today? Because OpenAI just upgrade their model, or they just make the model like dumber, right? Those are the things we're constantly dealing with. The non-deterministic behavior of the generative AI is hard, right? So we have never encountered things like this before. So that's why I mentioned, like, you can build a really cool demo, probably worked only 1 out of 100 times. But if you make sure, trying to make sure everything is working like from 90% of the time, you need to like, that's a very hard engineering problem to solve.
Okay.
Yeah, so that's why I find like anything that's it involves in the generative AI model is going to be hard. And if you really want to productionize it, it's going to be really, really even harder problems. Another thing I realized is like,
I felt the long nights when you said that. Just all of that stuff is what we've been hearing time and time again on this podcast, and you're not alone there. The inconsistent responses, that's why like evaluation is such an important piece of this. The slow responses, I think a lot of people have abandoned a lot of use cases because they don't want to have to try and figure out how to make it faster. And so it's like, we'll just wait until it gets faster. Because for some people, like, that's not how the beer tastes good. It's not like if I make this and spend all this time and energy making this faster, what am I going to have to trade off in order to do that, right? And so that's another hard problem. So I feel for you.
Yes. Yeah, I think it make it stable, makes it run faster. It's going to be, it's a so different experience, like in the traditional AI world. And yeah, you have, so that's why you have to have really good engineering practice, like monitoring, benchmarks, evaluations. Most people, when they launch the product, they don't talk about those, right? Because they only talk about like, oh, the fancy product. But the harder problem is to how do you make sure is, you know, you have all the like tools you need to make it running stable.
Yeah, the reliability piece is so important, especially if you're going to put something out there for the public to use. One thing is putting it in a video and cutting out the pieces that you like. But we've seen time and time again that people will put it out for the public and then it just gets demolished because it's not that reliable. And so I think what happens is you get the marketing teams that will create these videos and show that like this is magical, and then it gets out into people's hands and they have such high expectations for what it's going to do, and it doesn't live up to that. It doesn't even live up to half of it. And so then you're like, this is a scam. What is this crap?
Yeah. I think this is so true. Like, because like, think about it, there's so many AI companies out there, right? You have to get your story heard first, right? But also like, you know, on the other side is, we all know the generative AI model is growing super fast, right? Maybe like the claims you trying to claim right now, you know, you cannot achieve that, but within a year or within half a year, you might be able to do that, right? So who knows? Yeah, so that's why like people afraid, like if they don't talk about this, they're going to miss out the opportunity, right? Another thing is like, I'm not claiming I know all the answers, right? I'm still like trying to improve the system at the same time, right? I can only claim, oh, my self-driving car can driving straight, like for 10 meters, like that's I can guarantee. But how it can go into like highways, like to do like detours, a lot of things, I don't have like the everything like ready like right now, right? So yeah.
And do you think that you just will need the training data? Like once you put it out there, just like with self-driving cars, the more miles that a car drives, the better it performs? Or is it something that because you are using so many third-party models?
Yes, I think when I designed the systems, the intent was, as we collecting more data, more real interactions, the system going to get smarter automatically, right? So so that's why we trying to launch early. Like maybe it doesn't work like 100% time, but like we are able to collect in those interactions during the phone calls, like to see how AI interacts with the actual humans in those phone calls. So by then, like we will starting to have more data. Like, so I think like I mentioned, eventually for different use cases, you will have a dedicated model for that case, right? For us, we want to have that dedicated model to representing you to make phone calls.
And when you say use cases, you mean like if I call my plumber versus if I call my hair salon?
It's more like, you know, what we're thinking of is people feel most painful is to dealing with customer support, dealing with random phone calls. We want to have those data, like how people actually engage in those conversations and how AI is deciding to like deal these phone calls. For example, if you're trying to call your like utility companies, like saying, oh, you have a power outage, right? What does their system look like, right? For example, it's more like, oh, you're driving to a new city, right? How their road looks like, right? How to get to the destination. and we're going to know, okay, how you actually be able to navigate through that. And we are recording kind of like to understanding during the process. So yeah, something like that.
I see. So right now you're just exploring roads and gathering that data. And so different companies that you call into, you're getting their customer service agents, which are probably also using AI these days.
Yeah, so that's why I talk about like a business has been using this for ages. They're trying to take advantage of you, right? Like, because you don't have like 2 hours or 3 hours waiting like for their humans, like saying, oh, I want to cancel my subscription. You know, they're going to say, oh, just get on this phone call like 3 hours later, they're going to cancel your subscription. They know you won't do that, right? So they're taking advantage of you. But now we're giving you the similar or even better AI to give the option back to you, saying, oh, you don't need to wait in line for that, right? Your AI going to do like everything for you, and then the business won't be able to take advantage of you.
Yeah, and it's almost like throwing it back in their face. Like, if I'm going to have to deal with these shitty chatbots, then I might as well have my own chatbot that can deal with them. And then if I need to be plugged in at some point, I can be. That's incredible. I'm very happy with the vision, and I appreciate you kind of peeking behind the hood or under the hood and showing us what you're doing and how you're working on these hard challenges. Is there any other like thing that comes up that you might want to give as words of wisdom to the listeners that are dealing and working with AI and ML day in, day out?
There's like the newer AI going to redefine all the new systems, right? But it's not going to be a easy path, an easy solution, easy like way out, like how to deploy those like in the systems. It's going to take it still take years for the AI agents really representing you to do a lot of things. I think right now is be open-minded to all the potential solutions and try them out, right? Try all the AI tools, try the AI things. Like, I think in the future, you will be the level of intelligence you can leverage only really going to define how productive you are, right? Think about like, oh, I can probably utilize 10 GPUs to GPUs of AI intelligence to make my life easier, or with someone can utilize 100 GPUs of AI to make their life better. I think in the future, that's how we think you are rich, right? You can leverage even more intelligence to make your life better.
That is a wild way of looking at it. Like, it's going to be, it's not currency. We're not going to play in US dollars. We're going to play in NVIDIA chips.
Yes.
Wonderful, man. Well, I am super thankful that you came on here and you did this with me. It was a blast talking to you. I am so excited for what you're building. And I mean, I wonder though, on your launch, not that I know much about launching companies or any of that, so it's almost like a armchair quarterback right here, so take it with a grain of salt. But don't you want to take a page out of the self-driving car book and just start in one area of like the US and start with one specific accent or one specific like company that you're trying to do or one specific use case?
Yes, like I mentioned, like we don't claim we have all the solutions, right? So, but we really want to hand the technology to you. I want to like we have our own critical use cases we think we're going to handle really well, but most of the cases we may not handle really well. But we want you, the user, to get a feeling of how powerful AI is and be able to utilize this, to battle like the bigger corporate. So that's why like we're trying to make sure like people who were suffered from the phone calls, and at least get the access, to see like our mobile app first.
what does the price structure look like for the consumer?
Yes. So for us, we want a ease of mind. And very interesting. Because whenever making phone calls, it's really, I don't know, why just in the US, the first time I'm trying to make a phone call, it's making me super nervous, right? I want this to be a ease of mind. Like when you're trying to make a phone call, you're thinking of the solution we have built for you. And so that's why we charge a kind of a flat subscription models. So then for any phone calls, you can go over that. So you don't need to worry about, oh, I have to make phone calls today, or I have to make phone calls tomorrow. Or there's something or the other side is speaking some language I don't understand, right?
Yeah.
So I want a ease of mind. So that's why we are charging a subscription fee, so that you don't need to worry about any phone calls at all.
And the reason I ask that is because I've heard people talk about this idea of, I really want my customers to engage with my product, but because I'm using third-party APIs, the more a customer engages with my product, that means the more API calls I'm making and the more money I'm spending.
A few things, we know everyone is doing token economy, right? And but I think as an end user, you care more about at the end user, you care more about can I get 10 AES solve my problem? As a company,
Yep.
If we find cheaper and still working solutions, we are making more profit, right? Think about it that way, right? We do our own calculation of how much token we consume, and for each phone calls, I think it's still makes sense for us to open up this in a subscription models.
Me as a consumer, I love that much more. I would rather do it like that than have to think about okay, should I use my credit for this AI phone call or should I just get on the phone?
Yeah.
So I feel you 100%. I'm super excited about what you're doing, Shaun. This is awesome.
Okay, see you. Thanks.